Engineering Mathematics, Linear Algebra Part 2. So these are some useful instructions. You can change the video quality by clicking at the bottom right corner of the YouTube video player. You can watch at least in 360 pixel for better quality. If the video is found very slow, you can change the speed of the video by changing at the bottom right corner of the YouTube video player. In the similar way, you can reduce the speed also. Please don't post unwanted comments and all about video quality, language, etc. These videos are prepared just for knowledge sharing for those who actually need it. If the video is found useful, please share our video and you can subscribe our channel for latest videos. You can ask questions and you can request videos on different topics. We will try our best to meet your requirements. So now we are going to the topic. This is Linear Algebra Part 2 lecture. In Part 1 lecture, we covered the different types of matrices. So here we are starting with a submatrix. What is a submatrix? A submatrix is a different matrices obtained from a mother matrix by deleting different rows and columns of the matrix. So I will explain with an example. So here is a 3 into 4 matrix, that is it is having 3 rows and 4 columns. I am deleting the last column, that is 6 7 2, and the last row 4 8 9 2. So I will get a 2 into 3 matrix which is marked in the red box. So that is a submatrix, that is a 2 into 3 submatrix of the main matrix. So in the similar way, I can delete the first column. So I will, if I am deleting the first column, that is 8 3 4, I will get a 3 into 3 matrix. So that is a different submatrix. In the similar way, I will get different types of matrices by deleting rows and columns alternately, by deleting 2 rows and 1 column and so on. And what are the different submatrices? A matrix is itself a submatrix of itself, which means that matrix A is a submatrix of itself, and we will get square submatrices and rectangular submatrices by deleting different rows and columns. Okay, so what are the different matrix operations? We will be covering the addition operation, subtraction operation, and multiplication operation. So first, addition and subtraction. So two matrices can be added only if they are of the same order, that it should be m by n and m by n. That is, if we are adding two matrices A and B, A should be of order m by n and B should be of order m by n. Then only we can add it, because there should be exactly m into n elements. So we can simply add or subtract the corresponding elements. So A plus B equal to C we will get. So for addition, that is, if we are adding A and B matrices, then the ij position we will get in the resultant matrix Aij plus Bij. I will show it with an example. For subtraction, it is same, Aij minus Bij. For example, so this is the first matrix, that is, we will call it as A matrix, and it is a 3 into 2 matrix, that is, it is having 3 rows and 2 columns, and the elements are denoted as A11, A12 and so on. The B matrix, it is also a 2 into 3 matrix, that 3 into 2 matrix, that is 3 rows and 2 columns. So both should be of the same order. Okay, both should be identical. So when adding, we are getting a different matrix C, that is the elements, it is also of the same order, that is 3 into 2, that is 3 by 2, or 3 rows and 2 columns. So when adding, so what is the operation that we have to do? Let us see here. That is C11 equal to A11 plus B11. That is, the identical positions are just added and put it in a different matrix. So C12 is equal to A12 plus B12 and so on. You can just see this. We are just adding same positions, adding, and we are putting in the next matrix same position. Okay, the operation is same for subtraction also. So for an example, I am taking an subtraction as an example. The operation is same for addition also with the plus sign. So the matrix A is a 3 into 3 matrix. It is having 3 rows and 3 columns, and the matrix B is also 3 into 3 matrix. It is having 3 rows and 3 columns. So when I am subtracting, I have to subtract the first A11 minus B11. So I will get C11, that is 4 minus 1. Then second, minus 3 minus 2. Then 1 minus 3, 0 minus 6, then 5 minus 7, minus 2 minus 9, then 5 minus 0, minus 6 minus 4, 0 minus 8. So I will get the matrix like this. So this is a the matrix obtained by after subtracting the A matrix and B matrix. So we will call it as C matrix. I hope you understand the matrix addition and subtraction. Okay, it is just simple. Add the just position, that is Aij plus Bij equal to Cij, or Aij minus Bij equal to Cij. So now we are going to discuss some properties of matrix addition. So the first property is commutative property of addition, that is simply A plus B equal to B plus A, because Aij plus Bij equal to Bij plus Aij. So the associate property is A plus B plus C equal to A plus B plus C. So that means that we have three matrices. First we are adding A, B plus C, and then we are adding A with that. So we will get a matrix. It is equal. First we are adding A plus B, A and B, then adding C. So this is the associative property. And additive identity property. For any matrix A, there is a unique matrix O such that A plus 0 equal to A plus O equal to A, where O is a null matrix. So which means that we have a matrix A and we are adding the null matrix with A, we will get the A itself. So there will always exist a null matrix. And additive inverse property also, which means that for every matrix A there exists a matrix minus A, then when we are adding both we will get S0, that is null matrix. Cancellation property is if we write A plus B equal to A plus C, then we can cancel A on the both sides, and so we can write B is equal to C. That is a cancellation property of addition. This is similar to the normal addition of numbers. Okay, so now we are going to the next operation, that is multiplication. So first we will discuss scalar multiplication, then we will discuss matrix multiplication. So scalar multiplication is nothing but multiplying a matrix with a scalar number. A scalar is a number. Scalar multiplication of matrix involve multiplying each element of the matrix by that number, which means that if we have a matrix and we have a number, so that number into matrix means every element in the matrix have to be multiplied with that number. So K is a scalar, and A11, A12, A21, A22 is a 2 by 2 square matrix. So after multiplying we will get KA11, KA12, KA21, KA22, which means each element in the matrix is multiplied with the number. Okay, so multiplication of matrices. The two matrices can be multiplied together only if the number of columns on the first matrix is equal to number of rows on the second matrix. This is a necessary criteria for multiplication of matrices. If the two matrices A and B satisfying this criteria, that is number of columns on the first matrix is equal to number of rows on the second matrix, then only we can multiply those matrices. Otherwise we can't multiply those matrices. I will explain that. So A is a matrix of order m by n, that is m rows and n columns. So B is a matrix of size n by p, that is n rows and p columns. Then we can see that number of columns in A equal to number of rows in the B, that is m by n and n by p. So these two should be, that is n, same, then only we can multiply. When we are multiplying the matrix, we will get a matrix C which will have the size m by p. Okay, I hope you understand this. A is m by n, then B is n by p, then we will get m by p matrix. So we will explain. So with an example, so A is a matrix of 3 by 3 order. It is on 3 rows and 3 columns. So we can only multiply a matrix with 3 rows with A. Okay, so B is of order 3 by 2. When 3 by 2, we will get after multiplication we will get the matrix of order 3 by 2. How? Because number of rows of A into number of columns of B. C is 3 by 2. So here is a example. A11 is a matrix of order 3 by 3 matrix, and B is of 3 by 2 matrix. So when we are multiplying, we will get a matrix of 3 by 2 order. So how the multiplication is done, this is explained here. Okay, so after multiplying we will get C11. Then how C11 is obtained? So first we will multiply the first row in the first matrix, that is A11, A12, A13 into the first column of the second matrix. So that is C11, we will get C11 equal to A11 plus A11 into B11 plus A12 into B21 plus A13 into B31. In that way we will get the C11, then C12 for C12, A11 into B12, then A12 into B22 and A13 into B32. That is the first row multiplied the first column, then we will get C11. Then first row multiplied by the second column, we will get C12. Then second row multiplied with the first column, we will get the second row first element. So in this way we will do the multiplication operation. So here is a worked example. It is just for a simple example. We have a 1 into 4 row matrix which is having only 1 rows and 4 columns, and we are multiplying with the column matrix 4 by 1 matrix. So we notice the matrix corresponding entries elements are multiplied. It is just an example, simple example. So we know that number of columns in the first matrix is 4 and number of rows in the second matrix is 4. So we can multiply those matrices. After multiplication, what will be the order of the matrix? It will be 1 by 1. Okay, I hope you got the concept. So how we are doing that? Here is an example. So the first matrix is of order 1 by 4, that is 1 2 3 4, and the second matrix is 4 by 1. It's a column matrix 5 6 7 8. So how we are multiplying? 1 into 5 plus 2 into 6 plus 3 into 7 plus 4 into 8. So after multiplying we will get 70. After some 70, it is a single element, because we will get, after multiplication we will get a 1 by 1 matrix, a matrix having only one element, that is one row and one column. It will be a single number, that is 70. Okay. So what are the properties of scalar multiplication? So associative property of multiplication, we have two scalars C, D, and the matrix A. So it is equal to C into D into A equal to C into D into A, which means that first we are multiplying the scalars, then multiplying with A. It is equal to, we are multiplying the D with A, that is we will get TA into C. Okay. Distributive property, C into A plus B is equal to CA plus CB, which means that we have the matrix A and we have another matrix B. We are adding it, we will get A plus B, then we are multiplying it with the scalar C. It is equal to the first scalar into first matrix, that is C into A, plus scalar into second matrix. Okay. For two scalars it is C plus D into A equal to CA plus DA. So multiplicative identity property, okay, 1 into A equal to A into 1, or I into A equal to AI into I. We can also write it like that. Then multiplicative properties of 0, that is 0 into A equal to 0, and C into O means null matrix is equal to O itself. O is the null matrix. Okay. Closure property of multiplication, CA is a matrix of the same dimensions of A. So we have A is a m by n matrix and we are multiplying it with a scalar C. Whatever the value of C, after multiplication we will get a matrix of order m by n. Okay. So now we are going to the properties of matrix multiplication. You should note that the commutative property of multiplication does not hold good for matrix multiplication, that is A into B not equal to B into A, which means that we know that for doing A into B, the number of columns in A equal to number of rows in the B, but for doing the reverse it should not match, because number of B into A, for doing B into A, number of columns in the B should be equal to number of rows into A. This kind of a property is possible only for square matrices, but it will not give the same result, that is A into B may not be equal to B into A. Then associative property, A into B into C equal to A into B into C. First we are multiplying A and B, then multiplying with the C. It will be equal to B into C into A. Then distributive property, A into B plus C is equal to AB plus AC. Then B plus C into A equal to BA plus CA. These are simple properties just for your knowledge. Then multiplicative identity properties, that is identity matrix into A equal to, we will get A itself. In the similar way, A into identity matrix we will get A itself. Note that A should be of order of the same order of that of A. Okay. Multiplicative property of 0, that is a null matrix into A we will get null matrix, and A into null matrix we will get null matrix. The dimension property, a product of the matrix m by n matrix and the n by k matrix, after the product we will get a matrix C which will be of order m by k. So this is the dimension property. So now we are going to the concept of inverse of the matrix. And for an n by n matrix A, that is a square matrix, there exists a matrix B such that A into B equal to identity matrix, or B into A equal to identity matrix. So the matrix B is called inverse of the matrix A. Okay, so the inverse is analogous to reciprocal, that is A into 1 by A equal to 1. Okay, so a matrix are two types, that is singular matrix and non-singular matrix. These concepts are explained in the last lecture, so I'm explaining again. So non-singular matrix means a matrix having non-zero determinant. So for existing the inverse for a matrix, the matrix should be non-singular. That means the determinant of the matrix should not be 0. So for matrices which are singular, that is determinant equal to 0, the matrix inverse does not exist. So the inverse exists only if determinant of A not equal to 0. This is a necessary criteria. Some questions are coming from this concept, because for existing, what is the value of K in the matrix when for the matrix should be non-singular. So we have to find the value of K for which the matrix will not become non-singular. So those kind of questions we will discuss at the end of the lectures. Okay, then properties of inverse matrices. So A inverse into whole inverse, that is, first we will find the A inverse, then again finding the inverse we will get the original matrix itself. Then K into A inverse, K is a scalar, so we will multiply the matrix A with a scalar K, and we are finding the inverse, which is equal to K inverse into A inverse, or A inverse by K for non-zero value of K, because 1 by K is coming, so K should not be 0. So A transpose into inverse is equal to A inverse into transpose. Then for any invertible m by n matrices A and B, AB whole inverse is equal to B inverse into A inverse. That is, when we are multiplying two matrices and finding the inverse, which is equal to B inverse into A inverse, the order will be changed. So determinant of A inverse is equal to determinant of A raised to inverse, or 1 by determinant of A. So this is an important property for finding the inverse of the matrix in objective type question. I will explain these important concepts again in problems, because these are very important ideas. You may thinking that these are just for reference and all, but will be very useful when solving problems. Then method to find the A inverse for a 2 by 2 matrix. There are simple method, simple equation, you just want to put the values in that. So let A equal to ABCD is a square matrix, 2 by 2 square matrix. Obviously for existing the inverse, determinant of A should not be equal to 0. That is, determinant of A is A into D minus B into C. That should not be equal to 0. That is, AD should not be equal to BC. If AD equal to BC, then determinant equal to 0. So first we will find the determinant AD minus BC, A into D minus B into C. Then A inverse is equal to 1 by determinant of A into, we will interchange the positions of A and D. So instead of A we will write D, and instead of D we will write A. Then B and C we will put just minus sign. So the inverse of the matrix A inverse, that is equal 1 by determinant of A into, that is determinant of A is AD minus BC, A into D minus B into C, and DA D minus B minus C minus A. This is a simple method for finding the inverse of 2 by 2 matrices. Okay, for 1 mark questions, this types of questions may come for find the inverse of the 2 by 2 matrix. You can just put the values and you can find the answer. So what are the steps to find the inverse of a 3 by 3 matrices? So for finding the inverse of a 3 by 3 matrix, there is a general convention, that is by computing the cofactor matrix, adjoint matrix, and then we will find the inverse of the matrix. So there are some steps called calculating the matrix of minors. So if we will find the minors, then we will form a matrix that is called a cofactor matrix. By computing the minor, we will get a matrix that is called cofactor matrices. Then the transpose of the cofactor matrix is called adjoint matrix, and the inverse of the matrix is adj A by determinant A, that is multiplying that adjoint matrix with 1 by determinant. Okay, so these are the steps for finding the 3 by 3 inverse of the 3 by 3 matrix. Let Aij be n by n matrix. Recall the cofactor Cij of element Aij is, that is how to find the cofactor. So cofactor Cij, that is C11, equal to minus 1 raised to I plus j, determinant of mij, that is minor value. So that is, if we want to find the cofactor of position A11, that is C11, then you have to do minus 1 raised to 1 plus 1 into minor. So this part we will explain with an example, so you will understand. So this is the equation. Find the cofactor element. So after finding each cofactor element, we can make a matrix that is called cofactor matrix. Put all the elements in the cofactor matrix, so this will be the cofactor matrix. It will be of the same order of the matrix A, the initial matrix whose inverse to be find out. Then we will find the transpose of the matrix, and then we will inverse of the matrix, transpose of the matrix we will get is adjoint. So the determ A inverse is equal to matrix of cofactors into transpose, that is adjoint of the matrix divided by determinant of A. Okay, so we know what is mean by transpose of the matrix. We are just interchanging the rows and columns. The rows are changed into columns and columns are changed into rows. Then we will get the transpose of the matrix. These concepts are explained in the previous lecture. If you are not clear about these lectures, please go through the first lecture, that is lecture 1. So the inverse of the matrix is A inverse is equal to 1 by determinant of A into matrix of cofactors, that is transpose of the matrix of cofactors, that is adj by determinant A. So here is an example. Calculate the inverse of the matrix B equal to 1 1 1 1 2 2 1 2 3 4. This is 3 by 3 matrix. So we have to find the cofactor matrix first. So minor. Okay, so first we are finding the cofactor for the element A11, C11, that is for the first element. What we will do, we will remove the row and column belong to that element. So for element 1, that is A11, it is the first row and first column we removed. Then we will get a 2 2 3 3, that is a 4 element. It's a 2 by 2 matrix. We can say that it's a 2 by 2 submatrix. So the determinant of this matrix is called a minor of the element A11. Okay, so the M11 we will get 2 into 4, that is 8, minus 2 into 3, that is 6, that is 8 minus 6, that is 2. Then cofactor is equal to 2. Why? Because my cofactor is minus 1 raised to 1 plus 1, then minus 1 raised to I plus j into determinant, that is determinant minor value, that's equal to C11 is equal to minus 1 raised to 1 plus 1 into the 2, that is equal to 2 itself. In the similar way, you can find the C12 value. How you will get the C12 value? Delete the column and row belong to that element, that is delete the first row and the second column. So you will get the element 1 2 2 4. Find the determinant and minus 1 raised to 1 plus 2, first 1 plus 2 into that determinant value. In this way you can find the cofactor values of all the elements. So you can put the cofactor values, and the determinant of the matrix is the first element into, that is 1 into the minor of that, minus second one into minor of that, plus 1 into minor of that. That minus sign is coming because of the minor. The minor of M12 will be always negative. Okay, so actually we have to put the plus sign here. Okay, for simple identification we wrote it like, it will be always like this. First will be positive, negative, then positive. Okay, when solving the problem you will understand how we are finding the inverse of the matrix and all. This is just for an concept. So we will get 2 minus 0 plus minus 1, that is equal to 1. Then using the formula B inverse equal to 1 by determinant of A into matrix of cofactors into transpose. By individually finding the cofactor values, we will get the cofactor matrix, and we will find the transpose of that, that is called adjoint of the matrix. The B inverse is equal to adjoint of A divided by determinant of B. Here the determinant is 1 itself, 1 by 1 into transpose of the cofactor matrix. This is a cofactor matrix, so we will get the inverse as this. Okay, now we are concluding the Algebra Part 2. Don't worry about the concept, because these concepts will be thoroughly cleared when solving the problems. Okay, so you can subscribe the channel and you can share the videos, you can request the videos if you like the channel. Thank you for watching. Thank you.